So in the last lecture, we have studied the Fibonacci search techniques. The one more technique which is in your syllabus, that is steepest descent method. Steepest descent search technique. Fibonacci में हमने क्या किया था? That we have given some interval A and B. And we calculate the value of x1, that was a plus fn minus 2 by fn into L0. L0 is the size of your interval. And x2 becomes fn minus 1 fn L0. ये हम करते थे फिबोनाइक में. क्या करते थे? फिर हम चेक कर लेते थे that my x1 is less than x2, और हम फंक्शन की वैल्यू चेक करते थे. If it is less, then I take the interval ax2. If it is greater, then I take the interval x1b, right? So now the next method is your steepest search, descent search techniques. So here, whenever you have to update your value in this Fibonacci, आपने क्या लिया था? x1 और x2. जैसे आप अपने numerical analysis में करते थे, that you take xi plus 1. न्यूटन्स में क्या कहते थे? xi minus function's value at xi divided by derivative, right? ऐसा कुछ बोलते थे ना. So the same you are doing here. So xi plus 1, here it will be xi plus lambda I into si, and your this si is nothing but this is lambda I into gradient of f of xi. Here your si is माइनस डेल्टा एफ ऑफ एक्स आई. तो यहाँ पे x आपका सिंगल वाला x नहीं है. Here your x can be anything like this, x1, x2. It can have n variables. So that means we are talking about the I plus 1th iteration. I plus 1th iteration क्या है? The solution at the ith iteration minus lambda I into your the gradient at f of xi, right? We will start the example. Right, then I will tell you the procedure. What is that? Like you do in your numerical analysis. So here, when we have terminated the Fibonacci, when we have terminated this, when I have reached up to your n is equal to 2, because further I can't do the calculation. So here your termination processes, it can be anything that can be given to you. It can be like this, that the function's value at xi plus 1 minus function's value at xi, that should be less than equal to your tolerance, right? Second, you can use also your xi plus 1 minus of xi, that can be less than equal to your tolerance. Third, the relative error which you take, xi plus 1 minus f of xi, divided it by the original value f of xi. So that will be less than your tolerance. And the fourth termination can be here your curl f by curl xi, that should be less than equal to epsilon 4, right? So these all are the tolerance level which will be given to you. So you have to stop whatever criteria will be given to you, right? So we will start the example. Instead of writing the steps, it would be better to go from the examples. So the first example is that minimize f of x is equal to x1 square minus x1 into x2 plus x2 square, so that error does not exceed by 0.05, that is f of xi plus 1 minus f of xi should be less than equal to 0.05. And the initial approximation is x is equal to 1, half. So here x is nothing. This is your x1, x2, because we have function in 2 variables. So this is my non-linear function. Clearly it is non-linear. We have degree 2 over here. So we have to minimize this function and This is my termination criteria that I can stop only when my error will be less than 0.05 in the function. And you have to take the initial approximation here is x1, that is your 1 into 1 comma half. That is your, this is your point x1 and this is your point x2. So what is the process? That we have to calculate xi plus 1, xi minus I need lambda I into gradient at f of xi. यही चाहिए मुझे कैलकुलेट करने के लिए. So if I want to calculate the gradient, gradient आपका क्या होता है? So if we have a function f of x is equal to this thing x1 square minus x1 into x2 plus x2 square. So the gradient of f of x means here you will have curl f by curl x1 comma curl f by curl x2. You will partial differentiate. Gradient में यही करते थे ना? That you find the point. So it will have your 2x1 minus x2 if you will partial differentiate minus x1 plus 2x2. So this is your gradient. Now, as per the formula, we have xi is equal to xi minus lambda into gradient of f of xi. And if we have to start from I is equal to 1, we will calculate x2, that will be x1 minus lambda 1 into the gradient at fx1. That means my x1 point is 1 comma half minus lambda 1 point is same as lambda 1, and your delta of f of x is your, you will substitute the point, x1 is your 1 minus half, here it is your minus 1 plus 2 into half. You are substituting the value of x1. Here you have x1 is your 1 comma half. That means in place of x1 you will substitute 1, and in place of x2 you will substitute the value of x2, that is your half. So when you will calculate, you will get, this is coming as 2 minus 3 lambda 1 by 2 comma 1 by 2. So this is your value at x2. You have to stop and you have to check the function's value at f of xi plus 1 minus f of xi, right? इसका मतलब क्या है कि you have to substitute this value in your function, or this is the method that whenever you will calculate any value, you will substitute this value in your function f of x2. x2 आपका function क्या है? x2 अब आपकी value क्या है? That on place of x1 you will substitute 2 minus 3 lambda 1 by 2, and in place of x2 you will substitute 1 by 2 in the function f of x. Clear? So what will be this? This will be 2 minus 3 lambda 1 upon 2 square minus x1 2 minus 3 lambda 1 by 2 into your x2 is your half plus x2 square. Fine. So when you have any function, you want to find the stationary point where your function should be maximum or minimum. What is the necessary and sufficient condition that you do in your calculus part? Whenever you have any function, what is the necessary and sufficient condition to find the stationary point? Extrema point, your point of minimum. That you take the partial derivative with respect to any variable that you take equal to 0. So since we have function this and we have this equation in terms of lambda 1, so if I want to find the value, so what I have to do, I have to do curl f by curl lambda 1, that is equal to 0. Is it clear? So when you will partially differentiate it with respect to lambda 1, partially kaho ya total differentiable ko, does not make sense because we have function in only one variable, right? So when you will solve this, you will get the lambda when value is your half. You can also use df by d lambda 1. Clear है ये चीज? Lambda 1 अब आपको पता चल गया. इसका मतलब मेरा x2 point क्या आया? That is my 2 minus 3 into 1 by 2 upon 2, 1 by 2. So that's the point you got. This is your 1 by 4 comma 1 by 2. Is it clear? अप्रोक्सीमेशन फाइंड करनी है ना, पहले हमें x1 था, फिर हमने x2 फाइंड करना था. बट व्हेन वी हैव टू फाइंड x2, this is the formula, but here the lambda was introduced. So to eliminate the lambda, we have substituted the value of the function, value of the variable in the function. Then we differentiate the function with respect to lambda and we will find the value of lambda. Then we will go back and substitute it in the given approximation that we have calculated after the next approximation. So you have calculated x2. अब आपको stop कब करना है? जब आपका xi plus 1 minus of f of xi should be less than 0.05. So in this step, you can check your f of x2 minus f of x1 is not less than equal to 0.05. That means you can't stop here. You can check the value, right? So the next step, we again go to step 2. Like for the given approximation, we have taken x1 as 1,2. Now what will be my next approximation? That we have calculated. My next approximation will be x2 is equal to 1 by 4, 1 by 2. And I will calculate now the value of x3. What will be my x3? x2 minus lambda 2 into the, because you have used lambda 1, that's why I'm giving the name lambda 2. The gradient of f at x2. x2 अब आपका क्या है? 1 by 4, 1 by 2 minus lambda 2 is your, you have to find, you will substitute the values in the function, that is your 2 into your x1, that is 1 by 4 minus x2, that is your 1 by 2 minus x1 plus 2x2. So when you will calculate, you will get the value that is your 1 by, that you will get the value 1 by 4, 2 minus 3 lambda 2 by 4. The next step is, we have to substitute this x2 value in the function. So we have function of, we will substitute the value of x2, that will, in the place of x1, we will substitute 1 by 4, and in place of x2, we will substitute 2 minus 3 lambda 2 by 4. So you will get equation 1 by 16 minus 2 minus 3 lambda 2 into your 16 plus 2 minus 3 lambda 2 by 16 whole square. The next step is to remove lambda 2. So for that, what we will do? Curl f or df by d lambda 2, that you equate it to 0, and you will get the value of lambda 2 as half. So that means the point here, your x3 is, it is coming as 1 by 4, 2 minus 3 into 1 by 2, that is by 4, and you are getting the point here 1 by 4, 1 by 8. So next point that you got, that is your x3 is 1 by 4 and 1 by 8. So you can check the function's value at x3. This is your 3 by 64. Function's value at x3 minus function value at x2. This you will get 9 by 64 when you will do. That is your less than 0.05. That means we have obtained the approximate optimal solution. Therefore, the approximate optimal solution is your point 1 by 4, 1 by 8, and you can find the value at this function, and you can find the minimum value that you will just substitute, that is your 3 by 64. Clear? Yes or no? Clear to all? So this is all about your search techniques. Next, the last chapter, or you can, the last topic. Now we have a non-linear programming problem that we have already started, but we were finding the approximate solution for the nonlinear programming problem. When we have started nonlinear programming, I have told you that it is not easy to find the optimal solution in case of nonlinear programming problem, because my optimal solution can lie within the feasible region. That we have done the example of the circle, right? So when we will do NLPP, we will do without constraints. That means you have only the objective function. And we will do with constraints. In without constraint, that means you have only the objective function. We will go for the method Hessian matrix that I will tell you today. And if you have with constraints, and we will divide this, sign of all the constraints are of equal to type, and sign of at least one constraint is not equal to type. That means it can be less than or it can be greater than, right? So if you have this thing, for this we will use the Lagrange multiplier method. That we will discuss in this class. And for this, we will go for the KKT method. The Karush-Kuhn-Tucker conditions, right? KKT का नाम है. In some of the books, it is written only Kuhn-Tucker. But जब इन्होंने ये develop करी थी, इससे पहले इन्होंने किसी ने develop कर रखी थी, and that person has submitted the thesis. तो ये KT condition से दोबारा उसका नाम हुआ था कि that should be called KKT conditions. So, firstly, we will discuss. Now we have NLPP. We are going to discuss without constraints. If it is without constraint, that means only we have function, that is f of x, that we have to either maximize or minimize. So for that, we will firstly find the stationary points, because we have only one function जिसको हमने maximize या minimize करना है. Then we will find the stationary points. Stationary points, how you will find? That we have already done now. The necessary and sufficient condition for any function to find the stationary point is that you take its partial derivative or the total derivative that is equal to 0. So if you have any function f of x that is of n variables, but we find the stationary points by differentiating it with respect to xi, and we equate it to 0. That is, and I is equal to 1 to जितने भी आपके variables हैं n. So that means curl f by curl x1 equal to 0, curl f by curl x2 equal to 0, and all that. So when you will solve these equations, and we will get the value x1, x2, xn, that we call the stationary point. Is this clear? Fine. So how do you say this stationary point which you have evaluated is minimum, maximum, or it can be a saddle point? So the nature of stationary point means a point x1, x2, xn will be point of maxima if the Hessian matrix corresponding to x1, x2, xn is negative semi-definite or negative definite. Do you remember negative definite, semi-definite? No? I will explain. Firstly, you just write, then I will explain, right? The second is the same. A stationary point will be a point of minima if the Hessian matrix corresponding to x1, x2 is positive semi-definite or positive definite. And the last, a point x1, x2 will be saddle point if the Hessian matrix corresponding to x1, x2, xn is indefinite. Right? Firstly, I will tell you what is positive definite. However, you have done this. So because we have to use this, so I will explain. So when we are talking about matrix, that means we have any matrix. We suppose we have A matrix is A11, A12, A1n, we have variables A21, A22, A2n, AM1, AM2, and AMN. So suppose this is the matrix, right? When do you call this positive definite or positive semi-definite? If you take the principal minor determinant starting from the lowest order, that it is greater than 0. That means the lowest order, सबसे lowest order इस matrix में क्या होगा? This is your m cross n matrix, 1 cross 1. 1 cross 1, that means you have to consider only this matrix. So that you will call as D1A11. ठीक है? कोई और एलिमेंट नहीं ले सकते, आपको डायगोनल ऐसे भी बनता है. So we have to take the principal diagonal that is only corresponding to your this side, right? So you will take A11, then you take the matrix of A22, that is you find the determinant A11, A12, A21, A22. Again for a D3, what you will have? The 3 cross 3 matrix. And so on. Clear? That you will move forward whenever what will be your order of the matrix. So you will say your matrix A is positive definite if you have D1 that should be greater than 0. D2 is also greater than 0. And so on. That means that your all di's should be greater than equal to 0 for I is equal to 1 to जितने भी आपकी cross की m cross n नहीं होगी, that you have to take the determinant. So that means you have to consider only your n cross n matrix, right? So for all this should be greater than 0. And when do you say your positive semi-definite? When you have D1 is greater than 0, D2 can be greater or equal to 0, D3 can be equal to 0. So that you say positive semi-definite. That means for that, only your D1 should be greater than 0 and all other DIs can be greater than equal to 0 for I not equal to 1, and that you can take other values for I is equal to 2, 3 up to so on. Is it clear? So the definition of positive definite, positive semi-definite, clear? Yes. In the same way, you will say your matrix A is negative definite when you will have D1 is less than 0 and then you have alternate sign. D2 greater than 0, D3 less than 0, D4 greater than 0, and so on. That means DI for the odd, it should be less than 0, and DI for the even, it should be greater than 0. So that you call as negative definite. Is it clear? Negative semi-definite the same. A is negative semi-definite. When you have only the condition for the first, that D1 should be less than 0 and your D2 either can be greater than 0, D3 can be less than equal to 0 and D4 can be greater than equal to 0 and so on. So that means here only D1 should be D1 should be less than 0 and all Di can have alternate sign that can be greater or less depending on the even and odd. So that should be greater or less, right? That only you have to check this D1 should be less than 0. Clear? Yes or no? Okay. Next we are using the Hessian matrix. ये तो simple matrix थी जिसके बारे में मैंने आपको बताया. ठीक है. Hessian matrix is that if you have any function of n variables, then you say your Hessian matrix is when you take the partial double derivative for the first variable with every variable, curl to f curl x1 into curl xn, फिर curl to f by curl x2 into curl x1, curl to f by curl x2 square, curl to f curl, that will be your x2 xn, and so on. You will have curl to f curl xn, curl x1, curl to have curl xn, curl x2, curl to f curl xn square. That means you will take the double partial derivative of every variable with others variable. That means it will be always will be of your n cross n order. ठीक है. अब हेशियन मैट्रिक्स आपकी मैट्रिक्स ही बन जाएगी. ठीक है. उसमें आप अपने चेक करोगे कि क्या वो पॉजिटिव डेफिनेट है या नेगेटिव डेफिनेट है. Then you will say that the point which you will obtain, that is a point of minima or maxima, right? We will do the example. So example is if f of x is given to you 2 plus 2x1 plus 3x2 minus x1 square minus x2 square. How do you find the stationary point? And you have to check that, find the stationary point and check the nature, right? So in this, you will equate curl f by curl x1 firstly equal to 0, curl f by curl x2 equal to 0. कर लोगे equate? You will have two equation in two variables so that you can solve and you will get the value that will be your x1 is getting as 1 and x2 will be your 3 by 2, right? Next step is you have got the point now x1 and x2. This is coming as 1, 3 by 2. Next step is we have to construct the Hessian matrix. अब हमें function given है, we will consider curl to f by curl x1 square, curl to f by curl x1 curl x2 because we have only two variables, curl to f curl x2 curl x1, curl to f by curl x2 square. So that is coming as your values -2, 0, 0, -2. Suppose जब आप partially differentiate कर रहे हो, you will have some here x1 और x2 बच जाते हैं. Then you will substitute these values x1 because you are finding the Hessian matrix corresponding to your point, stationary point. Clear? So here you can see your D1 is your -2, that is your less than 0. D2 is the determinant of -2, 0, -2, that is your 4, that is your greater than 0, which implies H is my positive definite or negative definite. So H is negative definite matrix. Therefore, the point 1, 3 by 2 is a point of maxima. Clear? Or the question was that identify the stationary point and nature, right? You can do one more example. That if you have find the stationary points, the same question, and classify the following function or tell the nature of the stationary point. X1 square, x2 square plus 3x3 square minus 2x1 into x2 plus x1 into x3 plus 16, right? Whenever you have given function, you have to find the stationary point. The first step is we have to curl f by curl x1 equal to 0. We have three variables here, curl f by curl x2 equal to 0 and curl f by curl x3 that we will equate to 0. So when you will do this, this is your 2x1 minus 2x2 plus x3, you equate to 0. This is 2x1 minus 2x2 minus 2x1 equated to 0. And this will be your 6x3 plus x1 equal to 0. So when you will solve this, you will get the value of x1, x2 and x3 as 0, 0, 0, right? The next step is you will construct the Hessian matrix. Now you have three variables. So Hessian matrix will be of your 3 cross 3 order. So that will be curl to f by curl x1 square, curl to f by curl x1, curl x2, curl to f by curl x1, curl x3, and here for your x2 and here for your x3. So the matrix is coming here as 2, minus 2, 1, minus 2, 2, 0, 1, 0, 0. So this is your matrix. Next you have to check this is positive definite, positive semi-definite, negative or negative semi. So for that we have the first D1 entry is 2, that is my greater than 0. D2 entry is 2 minus 2 minus 2, 2. So the determinant here is coming as, so here the determinant here is 0. And if you calculate your D3, that you take the 3 cross 3 matrix, the value here coming as negative. So is it forming any sequence? So that therefore H is indefinite, which implies the point 0, 0, 0, which we have obtained the stationary point, is a saddle point. Here your function is neither maximum nor minimum. Clear? So whenever you have any LPP without constraints, you have to always go for your Hessian matrix, right? Find the stationary point, construct Hessian matrix and check its nature, right? Next, we are going to do NLPP with equality constraints. Then here your function will be either that should be optimization f of x, it can be maximize or anything, right? And minimize. And subject to, you will have constraints gix, because we are saying we have equality constraints. I am saying gix is equal to 0. 0 means whatever you have on the right hand side b, you can shift it into the left side. So that becomes your 0 on the right hand side. For all I is equal to 1 to m. And any of your f of x or any of your gx can be nonlinear, right? So what we will do in this case, we will create a Lagrange function that we will create by Lx lambda, and that will be the optimization function which we have, plus we will multiply lambda with every constraint and we will sum. That means summation I is equal to 1 to m lambda I into gi of x. Clear? Again, हमारे पास अब जो प्रॉब्लम, ये जब आपने Lagrange फंक्शन बनाया, so your problem has been converted actually into NLPP without constraints. ठीक है? उसमें हमने क्या किया था, that we have find the stationary points. Stationary points हमने कैसे लिए थे, curl f by curl xi. But अब हमारा फंक्शन क्या है, curl l by curl xi you equated to 0, and you have curl l by curl lambda you equated to 0. And for I is equal to 1 to m. Is this clear? Yes or no? Because now you will have x1 and lambdas. वहां पे हमने Hessian matrix construct करी थी. Here we will construct the bordered Hessian matrix. Bordered Hessian matrix. And what will be that? This we denote by HP, and this is the null matrix, and this is your P matrix, and here you will have P transpose, and here you will have Q matrix. Whereas P is the matrix of the partial differentiate of your constraints, that is curl G1 by curl X1, curl G2 by curl G1 by curl X2. First constraint with every variable. Then you will have second constraint with every variable. Then you will have mth constraint with every variable. So what will be the order of this matrix? M cross n. You have m constraints, but you have n variables. And P transpose means just the transpose of the matrix. And what will be the order of this then? N cross m, right? And Q is your matrix, which is your matrix for your very function that you will have curl to f. Sorry, curl, because we have function now, curl to L, curl x1 square. That is the Hessian matrix which we have constructed for the function. Now we have function is our Lagrange function L. So that will be curl to L by curl x1 into curl x2. Curl to L by curl x1, curl xn, and so on. Curl to L by curl xn, curl x1. Curl to L only for the variables, not for the lambdas, right? These lambdas sometimes we call Lagrange multipliers. ये eigen values नहीं है. These are your Lagrange multipliers, right? That's why name is Lagrange multiplier method. So curl xn, that will be your square. What will be the order of this? N cross n, right? अब आप जीरो नल मैट्रिक्स का ऑर्डर खुद डिसाइड करना कि क्या होना चाहिए. यहाँ पे आपको पी मैट्रिक्स कितने ऑर्डर की है आपकी एम क्रॉस एन की. इसका मतलब यहाँ पे आपकी जीरो में कितनी रोज आएंगी? ऑब्वियसली the same number of rows you will get for whatever you will have P matrix. This will be your P or M cross M. Because that matrix you will have N cross M order and the columns there will be your M. So it will be your M cross M. This can be your quiz part, right? Zeros का matrix, ठीक है? So वहां पे हम पॉजिटिव डेफिनेट की बात कर रहे थे. यहाँ पे हम पॉइंट को मैक्सिमाइज या मिनिमम कब कहेंगे? इफ डी आई स्टार्ट्स फ्रॉम साइन -1 m+1 and changes alternatively when I is greater than equal to 2m+1, then point is minima point that you have function as if di starts from sign -1 and remains the same where I is greater than equal to 2m+1 and m is your constraint here, then we have the point of maximum. अब यहाँ पे आपको D1 से स्टार्ट नहीं करना है, D2 से भी स्टार्ट नहीं करना है, that you have to select only start from I equal to 2m+1. मतलब जो आपको D निकालने हैं वो आपको 2m+1 से निकालने हैं, ठीक है? The question is that you have to optimize the function f of x. You have 4x1 square plus 2x2 square plus x3 square minus 4x1 into x2 subject to you have constraint x1 plus x2 plus x3 you have equal to 15. 2x1 minus x2 plus 2x3 that will be your 20 and x1 x2 x3 all are greater than equal to 0. ऑप्टिमाइज मीन्स आपको बताना है कि ये फंक्शन जो है मिनिमम होगा या मैक्सिमम. Because we have all the constraints are of equal to type, then we can create our Lagrange function Lx that will be function of f of x, that is 4x1 square plus 2x2 square plus x3 square minus 4x1 into x2 plus lambda 1 times the first constraint. और मैंने वहां पे क्या लिखा था, gix is equal to 0. That means here you will have to write minus 15. Is it clear? Yes or no? क्या है? Plus lambda 2 times 2x1 minus x2 plus 2x3 minus 20. So whatever you will have on your right hand side, you will shift into your left hand side so that your constraints becomes equal to 0. So since we have calculated L, so next task is to construct the Hessian border. Next task is to find the stationary point. So the stationary point we will find curl by curl x1 that equated to 0, curl L by curl x2 we will equate it to 0, curl L by curl x3 we will equate 0, and we will equate curl L by curl lambda 1 equal to 0, curl L by curl lambda 2 equal to 0. If you will have one constraint, you will have only plus lambda 1 into that constraint. If you have more constraint, that Lagrange multipliers you will keep on adding, plus lambda 1 into first, plus lambda into 2 second, plus lambda 3 into third. Solve kar loge equations, whatever you will get. So when you will solve this equation, you will get, you are getting from here, x1 you are getting here, this is your 11 by 3, x2 you will get 10 by 3, x3 you will get 8, lambda 1 you will get minus 40 by 9, lambda 2 you will get minus 52 by 9. Next step is to construct the Hessian bordered matrix. उसके लिए मुझे क्या चाहिए, पहले P, that is the curl G1 by curl x1, curl G1 by curl x2, curl G1 by curl x3. Curl G2 by curl x1, same for x2, curl G2 by curl x3. So when you will calculate at the stationary point, अगर आपके x1, x2 की values इसमें रह भी जाती हैं, you will substitute these values, right? So you will get the answer is 1, 1, 1, 2, minus 1, 2. The P transpose is just the transpose of this matrix. 1, 1, 1, 2, minus 1, and 2. Q is the matrix for the Lagrange's curl to L by curl x1 square, curl to L by curl x1 into x2, curl to L by curl x1 x3, and you can calculate the further. So this is coming as eight minus 4, 0, minus 4, 4, 0, 0, 0, 2, right? Now we will construct the Hessian bordered matrix. अगर आपको confusion हो order लेने में, आप पहले P लिख लिया करो. So you can write here 1, 1, 1, 2 minus 1, 2. इसका मतलब आपकी 0, 0 की दो तो है ही है. You can write the P transpose, that is your 1, 2, 1, minus 1, 1, 2. And this matrix, it means here is your 0, 0. And in this case, we have m is equal to kitne constraints hai? 2. So that my m is 2. And we have to start from calculating di from I greater than equal to 2m plus 1. So that means 2m plus 1, that is 2 into 2 plus 1, that will be your 5. 4 plus 1, that will be your 5. So that means you will calculate d5. सारा ही हो गया, ठीक है. So we have d5 that is coming out to be the determinant of this matrix 72, which is greater than 0, ठीक है. और इसका साइन क्या है? हमने क्या किया था? साइन या तो माइनस m प्लस 1 रहे या माइनस m रहे. किसके साथ मैच कर रहा है इसका साइन? एंड m we have 2. di का साइन. So we have 2, so that is positive and this is negative. Next हमें calculate करने ही नहीं है because we do not have order to calculate. So that is the same as sine minus 1 raised to the power m. Therefore, the point which you have calculated 11 by 3, 10 by 3, 8, that is the point of कौन सा point है? That is the point of max. Sorry, मैंने उल्टा लिख दिया वो. Here you have maximum and here you have minimum. Change कर लो, ठीक है. Exam में ना गलती कर देना, ठीक है. So that means this we have a point of minimum. क्लियर? अगर इसमें एक कंस्ट्रेंट होता तो आपका m कितना हो जाता? 1. तो आपका 2m प्लस 1 होता 3. तब आप डिटर्मिनेंट कहां से निकालना स्टार्ट करते? D3 से. 3 क्रॉस 3 ऑर्डर, 3 4 क्रॉस 4, 5 क्रॉस 5. फिर आप चेक करते कि किसके साथ आपका di का साइन मैच कर रहा है. फर्स्ट वाले di का क्या वो सेम रह रहा है या वो ऑल्टरनेट कर रहे हैं. अगर वो कोई फॉर्म नहीं करे, दैट मीन्स दैट इज योर सैडल पॉइंट. If it is forming a sign of minus 1 plus m plus 1 initially, then changes alternatively, that means that is the point of your maxima. Otherwise, if you have remaining the sign minus 1 raised to the power m, you have a sign of minima. Clear? Okay, thank you.